Okay, this is also complex numbers, general uh, problems, part 2. I power 50. I explained here why each power of 4, right? Each power of 4, I to each power of 4 is equal to 1. Let me before I do the I power 50 up here, let me make a general formula, right? So I to power any multiple of 4 for k, let's say, let's say for n, where n is a natural number or a whole number. So n could be 0. 0 times 4, 0. I power 0 is 1, as we can see here, right? I power n equal 1. I power 4 times 1 equal 4. I power 4 is equal to 1. N equals to 2. 4 times 2 is 8. I power 8 is equal to 1. N equal to 3, to 4, to 5, etc. It will be a multiple of 4 directly equal to 1. Let's do something else. If we have I power for n plus number, another number. This number could be 1. This number could be 2. This number could be 3, right? And this number couldn't be 4, because 4 plus 4, we can take it to the multiple of 4, right? So those are all the cases. I power 4n, if it is perfect power of n of 4, the answer is 1. I power 4n plus 1 is I to the power 4n times I to the power 1. According to formula, a power m times a power n is a power m plus n, right? A power m plus n. So here, I to the power 4n plus 1. What is I power 4n? It's 1 times I power 1. So it's 1 times I. Same for all, right? I to the power 4n times I to the power 2. I power 4n is a multiple of 4, so it's 1 times I squared. I squared is minus 1. Here, I to the power 4n times I to the power 3. So it's I power 4n, 1 times I power 3. And we found I power 3, which is I squared times I. I squared is minus 1 times I, so the answer is minus I. Let's do this one. It's I power 48 times I power 2. I power 48 is a power of 4, is a multiple of 4. I'm always saying power of 4. This is wrong. It's multiple of 4, because 48 equal 4 times 12. So it's multiple of 4. This means the answer is 1 directly. Times I square. I square is minus 1, so the final answer is minus 1. Let's do number 4. Number 4, we have to solve the quadratic equation 2x squared plus x plus 1 equals 0 over complex numbers. So not real numbers, complex numbers. We have more, right? We have more complex roots here. We have directly we find delta. It's quadratic equation, and delta is b squared minus 4ac, which is equal, b is equal to 1, so it's 1 squared, right? Plus minus right, minus 4. A is equal to 2 and C is equal also to 1. So the answer is 1 squared is 1, minus 4 times 2 times 1 is 8. It is minus 7. Usually, if we are not working with complex numbers, with complex roots, right, in set C, set of complex numbers, if we're working in set R, here we say directly it's negative, right? And that's why we, since it's negative, this means no real roots, no real roots, but we have complex roots. Why? Because the minus 1, minus 7 is equal to minus 1 times 7. And the minus 1, we can directly take it as what? As I squared. So this we can write it as 7i squared. When we have 7i squared, this means we have two distinct, different, complex roots, right? Because we can find the radical of this delta now. Minus 7, we can't put it inside the radical. But 7i squared, by removing the minus and put inside, instead of it I squared, we can find the roots. Alright? As we used to do usually. The first root is alpha. Alpha is equal minus b minus radical delta over 2a. And minus b is 1, right? b is 1, 1x. So minus 1 minus radical 7i squared over 2 times a, and a is 2, so over 4. The final answer of this, simplified answer of this, is minus 1 minus I squared can be taken outside the radical sign and will be I and 7 inside over 4. And the other root, b, is equal minus b plus radical delta over 2a. So the answer will be minus 1 plus I radical 7 over 4. These are the two roots because we're solving in complex plane. Number 5. Calculate z minus w, where z is given as complex number, w is given as complex number. And this is very nice, very simple, very easy. Z minus w. Z is 5 plus 10i. Minus w is minus 12 minus 8i. The answer is 5 plus 10i. Minus times minus 12 is plus 12. Minus times minus 8i is plus 8i. So we ended up with 5 plus 12 is 17, and 10i plus 8i is 18i. We added the real parts alone and the imaginary parts alone. So what is z minus w? Difference of two complex numbers is a complex number. It's 17 plus 18i. Let me do number 6. Let me do number 6. Okay, can we erase a little bit? Let me get rid of those. All right. We have to calculate. I still have time. Yes. We have to calculate 2z minus 3w, where z is given, w is given. That's nice. And both are complex numbers. 2 and 2 times z, 2 times 3 plus 8i. This is z. Minus 3w, 3 into 9, minus 4i. So it is equal to 6 plus 16i, minus 27 plus 12i. The final answer will be 6 minus 27 is minus 21. 16i plus 12i, it's 18. It's 28. 28i. Let me see if we have time. Yes, let's do one more. 7. 7. We have z. Z is 2 plus 3i. Find, I don't know if this is clear, find z bar, right? Find z bar. Z bar simply is this is z bar. Z bar is a symbol represents the conjugate of 2 plus 3i. It's directly the conjugate of 2 plus 3i is 2 minus 3i. What do we mean? That's it. This is the answer. But let me explain more. What do we mean by conjugate? In case you don't know, if we have z equal a plus ib, this means its conjugate is a minus ib. And why is that? And if it is a minus ib, it will be a plus ib, the conjugate. Why? Because the z times its conjugate, let's see what it is equal to. A plus ib into a minus ib. This is an identity, a plus b into a minus b, and it ends up with square the first minus square of the second, right? So it is a squared minus I squared b squared. And what is I squared? I squared is minus 1 times this minus here. We end up with a squared plus b squared, right? So we end up with a real number. If we multiply two conjugates, complex conjugates, this means we have to end up with a real number, no I in it. So if we multiply the 2 plus 3i with 2 minus 3i, the answer will be 4, because 2 square minus 3 square is 9, I square is I square. But what is I square? It's minus 1. So 4 minus 1 times minus 9, it's plus 9. The answer is 13. The answer is 13, right? So it's real. This one is real. Okay? Alright, see you next video.